So, so we're live right now.
Yeah, okay.
Okay, perfect. So you want to move on? So we want to move to number three, question number three.
Sure. Yes.
All right. Which hypothesis involves equality? It says.
Which hypothesis involves equality?
It's the null
The
hypothesis.
null hypothesis.
Mhm.
Do you agree,
I
Isai?
agree. I agree. Yeah.
Do you need speakers? Barely. Um,
Is it hard for you guys to
Okay.
hear me?
Much
Yes.
better. Thank you.
Much better. Okay. The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Question four. Remember that the p-value is the probability of a okay. When computing the p-value, which hypothesis do you assume to be true? Null, right?
Okay. See. The null hypothesis. I'll say the null hypothesis.
That's, I think so too. What do you think?
Yeah. Yeah.
Gabby?
Do you want me to read?
Oh, that's okay. I can continue reading.
Yes.
Question five said,
Okay.
which of the following presents the alternative hypothesis for two-tailed tests? Alternative hypothesis for two-tailed tests. Oh, I guess supposedly.
I think the third one. Yeah, me too. Surely not the fourth one. Yeah. The other one is one tail or the other tail. These equal, like not equal.
Third
Whatever.
one you said? Third one?
The third one. I think the third one.
How did you guys know if like what does it mean when it says like tail?
I didn't hear you, Isai.
Oh, sorry. What does it mean when it says an alternate like the two-tailed test? Like what tails?
What it means is that two-tailed, it means that you have to take in consideration the area that is after the positive z-score, but also before the negative z-score. So you're considering both tails, and you do that when you have an alternative hypothesis that has a not equal to.
Okay.
So you're considering both because you don't know if it's going to be lower or higher than the null hypothesis.
Uh-huh.
So
Okay.
when you have, so that's the case.
Okay, so perfect, makes sense. Okay, which of the following alternative hypothesis for left tail test? Would it be number two?
Would it be number two? Hmm. No, I would pick the first one.
First one.
Because it's the left. It's for something that's smaller.
Okay.
Okay. Do you hear a lot of echo, or is it fine?
That's fine.
It's fine. It's fine. Okay. So I would go with the first one.
Okay.
On question 6. I don't know. What do you say? Tail. So I gotta be smaller. Yeah, the first one. Okay. Question number 7. Is the opposite, right?
Yeah.
Yeah.
Number two.
So number 2. So yeah, I think so. Okay. So we're at 8.
Yeah. Which relationship would result in failing to reject the null hypothesis.
Okay, which relationship would result in failing to reject?
Alpha is, I don't remember the name, but it's what you use to see and to compare your p-value.
Okay, yeah.
It's called level of significance.
If P is
greater than the level of significance alpha,
yeah.
you are not rejecting the null hypothesis. Because you reject the null hypothesis when the p-value
is lower than alpha.
Or
the first one.
Okay.
Which relationship would result in rejecting the null hypothesis? Well, the second one.
Okay.
Where we said that. Which of the following would be the appropriate alternative hypothesis? Guess we need to know. An insurance company is reviewing its current policy rates. When originally setting the rate, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Okay, so the following would be appropriate alternative as a hypothesis. The average claim amount is greater than, so I think the third one.
Yeah, I would say so.
I think so.
And which of the following will be the appropriate null hypothesis? The average claim amount is equal to, so the first one.
Mm-hmm.
The insurance company randomly selects 40 claims and calculates a sample mean of $1,650. Use this information to answer the next 3 questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
I'll say yes.
Maybe since the first one.
Yeah. Yeah, because we don't know anything about the population.
Yeah, but it's 40. So
and I'm pretty sure it's going to be skewed either left or right because there's definitely going to be some outliers.
So do you think it's the first one or no?
I think so, yes.
Yeah.
Okay. Yeah.
What theorem or law justifies your answer to the previous question? The central limit theorem.
Yeah.
Law of total probability. We didn't even hear that.
Yeah, I never heard about it.
I don't even know if it exists.
Which of the following is the test statistic as defined in this lesson? Z. The Z-score test statistics.
Do you agree, Isaiah?
I don't remember actually that one.
Yeah.
Reading.
We can-
through.
I'm checking right now.
Are you? Okay.
Yeah, it is.
It's Z.
It's Z.
I just remember because it's my last name. The historical mean of sales versus recipes. What?
Receipts.
The historical mean of sales receipts at a grocery store is 150 with standard deviation of 40. The store manager suspects that the average has decreased. She sets up an hypothesis set to test with the hypothesis. Okay, null hypothesis is equal to 150 and the alternative hypothesis is 150. It's less than 150. Okay. She will use a level of significance of 0.05. She then takes a simple random sample of 36 sales receipts from her store and compute X to equal 100. Okay, what is the Z-score associated with this test?
So it's -6 over 40 divided by the square root of 36, let's say.
Minus 0.9.
Wait, is it the square root of what number? Was that?
Square root of 36,
36.
because she took 36 sales receipts.
I see. So 6 over 40 divided by negative 6.
How much does it come out?
Minus 0.9.
Is it? Trust me. Yeah. So 44.
Did you guys get minus 0.9?
Minus 0.9. That's what I got. But Daniel doesn't trust me, so he's doing
No,
it.
it's not that.
Shit.
It's just we're recording, and I want to look good, you know.
Oh, okay, you're showing off. Got it. Yeah. You should wear a wig.
Shut the heck up. I don't care, man. I'm pretty comfortable the way I am.
You should wear a wig if you want to look good.
Yeah, minus 0.9. Okay.
What is the p-value associated with the z-score from the previous question?
Okay.
No check. Okay. Però noi vogliamo evidenziare.
So it should be 0.1841.
Sai che è uscita molto.
Because she's checking if it's below.
Oh.
So that would be 0.4641.
No, 0.184.
Let's check that.
Wait, I put in the wrong number into the z-score, I think.
Okay.
0.1841, you said, right?
Yeah, we have to put 3 decimals, so 0.184.
Yeah. Okay.
So what inference would you make about the null hypothesis for this problem? I would fail to reject because it's definitely higher than 0.05.
Yeah, 9.5 or something like that.
That was our level of significance.
Okay.
What is your conclusion for this problem? We
There's
have
sufficient evidence that the population mean is 15. No. We have sufficient evidence that the true population mean is no. We have insufficient. No, we have.
I would go with the third one.
Okay.
Yeah, third one. It's less than.
Because that's what we're trying to demonstrate in trying to reject the null hypothesis.
Abbiamo rigettato, no?
No, we didn't reject it. We failed to reject it.
So yeah. 19, I believe, is the first one.
There are 2 types of errors. What can be made?
Yeah.
Yeah. Our researchers said that instead of using a level of significance of 0.5, 0.05, you will use one. Which of the following will be true? The probability of a type 1 error will increase. No. probability of type 2 error will increase. I think so, yeah. Probability of rule poses. I think the second one.
I think the first one.
Dang it, you're the tiebreaker.
I'm gonna go. Wait, why do you think? Why, Daniel? Why do you think it's the first one?
Because
Just
what
because I
happens-
said the opposite.
No, because what happens is that if you have a 0.01,
Okay.
you will have, it's going to be more likely that you will reject the null hypothesis. No, I said something stupid. It's the opposite. He's right.
Whoa!
Um,
I know, right? Feels
because
good.
0.01, it's what you are matching your results against. So you're going to be more likely
Mhm.
to keep your null hypothesis and to fail to reject it.
Okay.
I don't know,
Last
just true.
All right. Question 21. If alpha equals 0.05, compute the probability committing a type 1 error.
And that's the probability.
What's the question? If I compute the probability of committing a type.
That's what alpha is. It's the probability of a type 1 error.
So is it just 0.05 or?
Yeah.
I think so, yeah.
0.05.
I know. At first, I'm just like, I don't understand the question.
And that's what it said.
I'll do it. 0.05.
You see, we choose alpha to be some small number so that the probability of committing a type 1 error is low.
You're not leading this meeting, okay? May I submit, Isai?
Yeah.
Wait a
of
second.
course.
Go to
Oh.
something.
0.05.
Okay. Yeah, we did it right. Even though Daniel tried really hard to make us fall on a couple of them,
Really?
it's okay.
I didn't notice that.
It's okay.
All right. Cool. Good job, guys. I'll stop recording right now.